Hello students, my name is Shashank Shekhar and we are doing a crash course on chemistry for the upcoming JEE exam. And today is our 20th day. So we have completed the chapter that is ionic equilibrium in the previous class, and today we will be starting chemical kinetics. So the chapter today we will doing, the topic which we will covering today is basically order and molecularity and the rate law. And in the upcoming days, that is tomorrow and the day after tomorrow, we will be seeing the differential rate law and then the dependence of the rate constant on the temperature. So let us start with what is the rate of reaction. So we have studied the chapter chemical thermodynamics before this. So if you want to quantify a reaction, you can do it in two ways. First, you can predict whether a reaction will happen or not, that is, whether it is spontaneous or not. So you do that with the help of chemical thermodynamics. Now, if you have to tell that what is the rate of reaction or how fast the reactant or product will be formed, that is totally dependent upon the chemical kinetics. Suppose we have this conversion of carbon, or you can say carbon into a diamond. So this reaction is spontaneous inside the earth crust because of the high pressure and high temperature. But at the same time, this process is too slow to happen because its rate is very slow. So you can see a direct application of both the branches of this chemistry, that is thermodynamics and chemical kinetics. One deciding the spontaneity or the feasibility of the reaction, whereas the other, that is chemical kinetics, saying that this process will be slow. Now, if you want to say that what is the rate of a reaction, you can do it in two ways, in terms of the reactant as well as the product. So we'll see how it happens. So talking about the rate of reaction, first of all, we know that what is the rate of reaction? It is the change of concentration with respect to time. So suppose we are representing concentration with the help of molarity, that will be mole per liter per unit time, that is per second. So you can write it as further. So this is the hypothetical reaction that we have taken, that the reactant A is going to reactant B, where small a is the stoichiometric coefficient of capital A or the reactant, and the small b the stoichiometric coefficient of the product. Now, if you want to say the what is the rate of reaction in terms of the change in concentration with respect to a time, then it will be written as, suppose the concentration goes from A naught to AT, then the rate can be written as AT minus A naught, that is represented as change in concentration dA divided by A, and we have put up a negative sign for the reactant because rate can never be negative, and we know very well that as the reaction will proceed, the concentration of the reactant will decrease, and when we will calculate the change, that is final minus initial, we will get a negative value, but the rate can never have a value of negative. So to keep the sign convention correct, we put a negative sign before the reactant, while for the product it is written as 1 by b dv by dt. Now this term is called as rate of disappearance of A along with this negative sign. So you will consider this negative sign and you will exclude this term 1 by A, then you can call it as rate of disappearance of A. Similarly, this term here along with the positive sign is called of rate of appearance of B. So since we are going from reactant to product, so we are the A reactant is disappearing, so we are calculating the rate of disappearance of A to the product, that is rate of appearance of B. And for calculating the rate of the overall reaction, we have just to divide this rate of appearance of A by its stoichiometric coefficient, that is A, and for product we can divide it by B. So we will solve the question and we will make our concept more clearer. Before that, let us move to what are the type of rate of reaction. So there are basically two type of rates of reaction. The first one is average rate of reaction, and the second one is instantaneous rate of reaction. So what is the main difference between average rate of reaction is that we are calculating the rate of reaction over a wider, or you can say a greater interval of time. That means the delta t is large as compared to the instantaneous one, where we have taken dt, which is very small. So here I mean that delta t, that is for average, is greater than dt. So that is the only difference between this average and instantaneous rate of reaction. Now suppose we have to calculate the rate of reaction over a given time, that is from T1 to T2. Then we will simply subtract their concentration as T1 T2, that is R2 minus R1 divided by T2 minus T1, where R2 is concentration at A. So R2 is the concentration at A, T2, and R1 is the concentration as at T1. And this difference is called as delta R. And with a negative sign, I have told earlier that since we are uh, maintaining the sign convention, so if we are representing in terms of reactant, then we have to put the negative sign so that overall rate of reaction rate remains positive. Now similarly, the time will be delta T here, that is T2 minus T1. So this was all about the average rate of reaction. Now if you move to the instantaneous rate of reaction, so here let us, so this is for the average rate of reaction again, but in terms of product, and this one is in terms of reactant. Now if you move to this instantaneous rate of reaction, we can see here, so this is the R inst called the instantaneous rate of reaction. Suppose we have to calculate the rate of reaction at this point. So we are not considering a time interval likewise the other one, that is T2, and between T1 and T2 we are considering at a particular point. And what we do to calculate the rate of reaction is that we simply calculate the slope, and we know very well that if you have to calculate the slope of any reaction, sorry, of any curve, we simply differentiate it, that is dy by dx. So if y is this axis and dx is this axis, then it is dy by dx. So for this we have this concentration at y axis and x, that is time. So it will be change in concentration dr by dt at this instant. Okay, so this is the negative slope we are getting. So we are again using a negative sign along with this so that rate of reaction remains positive. So what we can see very clearly here also. So for that the concentration of the reactant is slowly diminishing. So we will get of course a negative slope here. Similarly, if we consider the instantaneous rate of reaction in terms of product, then it will be dp by dt with a positive sign in front of it. That is totally the slope of the reaction at that instant. So this was the main difference between the, so if you want to just conclude this discussion over this average instantaneous rate of reaction, you have to include this, that it is for the average rate of reaction, which is delta t, that means delta t is greater than this instantaneous rate, that is dt. So let us move to our next topic, which is about the rate law. Now let us move directly over rate law, then we will define all of its parameters that we have about the concentration, rate constant and all very clearly in the upcoming topics. So let us do this. So what is rate law? So if you want to define it, it is nothing but the rate of reaction in terms of concentration of the reactants raised to some power which can or cannot be equals to the stoichiometric coefficient multiplied by this rate constant, that is k, and it is determined theoretically, experimentally. Now this components of, you can see here that r, you can write here r also in place of rate of reaction r. So this r is equals to the rate of reaction, is k is called the rate constant, and a and b are the concentration of the reactants, that are a and b, and m plus n. So if you take this stoichiometric coefficient of a, that is m, and n, that is b, and add both of this, that is m plus n, then you will get the order of reaction. Now we'll see some properties of order of reaction in the later on slides, but for now just keep it in mind that what is rate law. So rate law is nothing but the rate of reaction expressed in terms of reactant concentration that are raised to some power that can be or cannot be equal to the stoichiometric coefficient, and which is overall multiplied by rate constant, that is k. So this is the rate law. Now let us see what can be the unit of this rate constant. So what do you mean by zero order reaction and first order and nth order? So let us again write this rate law, which is like this: r is equals to k. So suppose we are taking only one reactant, that is a. and it is raised to some power, say m. So by zero order I mean that m is equals to 0. Also, if it has two product, that is a and b, and both are raised to some power m and n, here also m plus n will be equals to 0 if this is a zero order reaction that is taking place between a and b. Now we know what is the unit of rate, so it is mole per liter per second. Also, we have to determine this k. Now since this m is equals to 0, that is, yeah, numericals, yes, Navinta, numericals we will solve in the means last slides after we will complete today's lecture, then we will solve questions on that. Okay, so here is the thing, that since A has the concentration of mole, so it is a concentration, so it will be mole per liter, per liter. Okay, now since it is raised to the power 0, it will have no contribution, and overall the rate constant will be mole per liter per second. So this will be for the zero order reaction. So the same thing written here, it is as mole per liter per second. Similarly, if you want to calculate it for first order, then you will get it as per second. Now let us generalize this rate of reaction in one formula. So it can be for the nth order written as mole 1 minus n minus 1 minus 1, where n is the order of reaction. So if you want, you can see the derivation very clearly here. So I have made a, you can say, a general form of it. So suppose this is our rate of reaction, which is written as R is equals to K A to the power n, where n is the order of reaction. So we know very well that rate of reaction is mole per liter per second, and K is written as it is. Now since concentration has the unit of mole per liter and it is raised to the power n, so what will be overall K? So it will be mole 1 minus n liter n minus 1 and per second. So this is for nth order. So you can remember this because questions are asked directly here, that say what is the unit of this rate constant for given order of reaction. Now let us move to the next thing. Now I've said earlier that the rate of reaction, so the order of reaction, can be equals to or not equals to this, say this stoichiometric coefficient. So we will see the case in which one the stoichiometric coefficient is equals to the rate order of the reaction and in which one not. So suppose if you are said in the question that the reaction that is given or the equation that is given is of an elementary reaction, then you will take simply the power, that is, suppose it is written that the coefficient of A is going to B and the coefficient of A is small a, then you will simply write the rate law as R is equals to K A raised to the power small a in case of elementary reaction. But in complex reaction you cannot do it so. So it has a different means it can be determined only theoretically if you know each and every step of that complex reaction. Until and unless it is not mentioned, you cannot find it. So for now, just keep in mind that unless and until it is not given that it is an elementary reaction, you will not take the coefficient as equals to the say order of reaction. Now what is an elementary reaction? Let us see the differences. It involves one step. The complex reaction involves multiple steps. Now the rate equation can be determined directly from the stoichiometric coefficient, as I said it earlier. But in case of complex reaction, the rate determining step determines that what will be the order of reaction. So what do you mean by the rate determining step? So the slowest process, suppose a reaction is taking place in 3 steps and the second step is the slowest step, then it will be determining the rate of reaction and we will take order of the reaction as per that step. So why is it so? So because this reaction will be affecting overall reaction more. So suppose a reaction is taking place in 10 seconds and 2 steps are occurring in just 1 second and 1 second and the remaining step is taking 8 seconds to happen. For that reason, we can clearly see that the overall rate of reaction is more and more affected by that slow step or the RDS. So that process, which is the slowest one, is called the rate determining step. And for a complex reaction, the order of reaction is totally dependent on that slowest step. Now the further thing is that Reaction rate can be experimentally determined through a single measurement. Yeah, it is true because we just take the coefficient. But in case of this, multiple steps had to be followed, and then we can find the rate of reaction. Now I will introduce to a new term, that is molecularity. So what do you mean molecularity? So if you want to put it in simple words, it is the number of molecules that collide together to form or to give a particular reactant. So most of the reaction have this as the value of 2 because it is very impossible for the collision to take in some orientation that three molecule collide in proper orientation and then give the product. So generally the molecularity of a reaction is 2. So it is the general idea. Do not take it as the means boundary line that okay, we will take the molecularity always as 2. Now what is this difference between order of reaction and molecularity of reaction? So it represent of the sum of the exponent of the concentration in terms of rate equation. So it's a basic definition we know about the order of reaction. And molecularity, what does it represent? It represents the number of reactants that collide together to give the reaction in an elementary reaction. So molecularity is only defined for elementary reaction and not for a complex equation. So suppose we get a okay, Navnita, the session will go on for 1 hour. So we'll not today completely cover this chemical kinetics. We'll cover only today order and rate of reaction. Then we'll today see the differential rate and all. So what I was talking about is that order of reaction only is applicable to all type of reaction, that is both elementary and complex, but molecularity is only meaningful for this elementary reaction. So this point is very crucial here. Now order of reaction can be determined experimentally and molecularity can be determined theoretically. So how is it so? So if we know the elementary rate equation, suppose it is like this, that A plus B gives C, then the molecularity will be 2 simply, given that it is an elementary reaction. But if it's it in case of this order of reaction, then you have to think about it. Now the main difference which you have to remember is that order of a reaction can be 0, can be fractional, or can be a whole number. So it can be anything. But it is not the case for molecularity because we know that it is the number of molecules that are colliding. So zero number of molecules cannot collide to give a reaction. Either half molecule cannot collide. It has to be one molecule or two molecule that should be colliding to give the reaction, or not colliding, at least transforming one molecule to another. So that is the reason we cannot take the molecularity of reaction as half, or you can say 0. So it should be always 1, 2, 3 or something like that. Now let us see illustration here to draw a proper boundary line between this order and molecularity. So consider reaction that is going from A plus B to C, and it is given that this reaction is elementary, means this is the only step that is occurring in the reaction, that is A is colliding with B to give the reactant, that is a product, that is C. So what will be the order of reaction? So it will be simply, since for elementary reaction I have earlier defined very well, that you have to simply take the coefficient of that. So it will be like rate is equals to K A B. Suppose this is small a, this is small b. So it is 1 written here. So it is raised to the power 1. So what is the order of reaction? So it will be simply m plus n, that is 2. So it is written 2. Similarly, what is the molecularity? It will be always also 2 because A and B, two molecules are there which are colliding, and since it is an elementary reaction, we can define it very well for this molecularity thing. Now let us move to another reaction that is complex in nature. Suppose this is a complex reaction that is given, that A plus B plus C gives D. Now say that it is happening in 2 steps. Suppose this reaction is happening in 2 steps. The first step is that A reacts with B to give X, and now this X transforms to D and we get our final product. Here the thing that is mentioned is that this step is the rate determining step. So you should keep this in mind, that this reaction is given, that is A plus B plus C is equals to D, and it is a complex reaction. It is happening in 2 steps. The first step is that A is reacting with B to give X, and X transforms to D, and this first step is the RDS, or the rate determining step, so it can be also written as RDS. Now suppose we have to calculate the order, so it will be simply the coefficient of these two added, because it is the RDS, we will take 1 plus 1, that is 2. Because nothing is written, we will take the coefficient as 1. Now let us talk about molecularity. Now we know that we cannot say that the molecularity of this reaction is 3. So it will be very wrong that if we say that the molecularity of this reaction is 3, because molecularity is not defined for any complex reaction, it is defined only for elementary reaction. Now we will define this molecularity for each and every step. So suppose we have taken the molecularity for the step 1. So we can see here two molecules are colliding to give X, so its molecularity will be 2. Similarly, in the second step, only one molecule is transforming into this D. So we will take it as 1. So this is the very difference between this molecularity and the order by two illustration, that is elementary reaction and complex reaction. I have shown it very well. Now we can move to some questions here. So let us see this question. So it says that the instantaneous rate of reaction for the given is this. So it is given, rate of reaction is given. What is the rate of appearance of I2? So we are given the rate of reaction and we are asked what is the rate of appearance of I2. So I have told you earlier that how you will write for the in terms of this I minus, sorry, it is given for I2, so this is I2. Okay, so this one, so we have to first write the rate of reaction in terms of I2. So this, since this is the product, it will have a positive sign. Let us write it. So it will be rate of reaction. So this one has a say a coefficient of 5, so it will be 1 by 5 dI by dt di2 by dt. So this will be the rate of reaction and it will have a positive sign. Why? Because we know very well that it is the product. So product is appearing and we do not need to put a negative sign as it will change the very concept of rate of reaction, which remains always positive. Now this value is given as 4.56 into 10 to the power minus 3. 4.56 into 10 to the power minus 3 m per second, that is molarity per second, or you can also write it as mole per liter per second. Now it is asked that we have to find this value, that is rate of appearance of di2 by dt. So I have written earlier also that rate of appearance should not include this coefficient, it should be only change in concentration of this say product with respect to time, and in case of reactant it will be change in concentration of reactant with respect to time. So I have to find this value. Okay, and this value is given for, sorry, for this value is given for the disappearance of MnO4 minus. Okay, so let me do it right. So if we just relate it with MnO4 minus, so it has a coefficient of 2, which will be given as 1 by 2 along with a negative sign, which will be dMnO4 minus by dt. Now if you put the values here of to find the dr by dt, sir, instead of dr by dt, can we also use the term delta? Yeah, you can use it, there is no problem with it. But since we are using this instantaneous rate of reaction is given, that's why I'm using D here. Okay, so if it is given in the question, you can see that instantaneous rate. So you will use this D. Okay, so you have to find this value. So it will be di2 by dt is equals to minus 5 by 2 into dMnO4 minus by dt. Now this rate of disappearance of MnO4 minus by dt is given already. So if you want to write, you can write it as di2 by dt is equals to, so if we replace this thing along with this, it will be 4.56 into 10 to the power minus 3. So if you calculate this, you will get your answer. So I have put the solution also here. So the rate of reaction is minus 1 by 2 is equals to this. So you will first relate this equation. Then we know that this value is given as 4.56 into 10 to the power minus 3. Then the rate of appearance will be 5 by 2 into this, which will be equals to 1.14 into 10 to the power minus 2 m per second. Now let us move to next question. So what does this question says is that the rate law for the reaction is given, that is R is equals to KRCl. So you can see here first of all that this reaction is a first order reaction. Why? Because its power is 1 here. So it is not written, so it is understood. So the order of reaction is 1. So if you solve a numerical, just note down things very quickly. First of all, the data that is given, you will be easy to solve this question. What is asked? The rate of the reaction will be. So what is the rate of reaction? Will be doubled on doubling the concentration. So let us see how we'll solve it. So it is given that R is equals to KRCl. So this is the rate law that is given, and it is given that it is independent of this NaOH, because this NaOH is not included in the rate law. So this NaOH, so this reaction is independent of the concentration of the sodium hydroxide. It is only dependent on the concentration of this alkyl chloride, and that is also to the power 1. Now it is saying that what happens if we double the concentration of sodium hydroxide. So the rate will, what will the effect on rate? So it will have no effect at all. Why? Because it is not present in the rate law. Second, half on reducing the concentration of, so it is saying that the rate is half on reducing the concentration of alkyl halide to is half. So say we reduce the concentration of this initial concentration by half. So what will be this new rate of reaction, that is R dash, if you have to find. So we can just equate this to, we can write it further this as 2R dash by K. So I'm writing this equation here is equals to RCl. Similarly, if you want to write this equation, it will be R by K into RCl. You can put this K here also because it is also constant. Now if you equate both of this equation, that is 1 and 2, you will find that the rate of this equation has become half of this initial. So the same statement is written here, that on halving the concentration of this alkyl halide, the rate of reaction will also be halved. So this is the correct statement. Now the next thing that is asked is that, so this one is right, wrong, this one is right, this one is wrong. So I'm just proofreading all of these options because so you do not get confused that why I have not eliminated this. So it says that decrease on increasing the temperature of reaction. So it is not anything mentioned about the reaction, that whether it is say exothermic and endothermic. So you cannot just predict the rate of reaction with the help of this statement only. So it is not right, and it is also not right. So overall this is the correct answer. Now let us see the options. Let us see the solution. It is given that as rate is equals to KCl, on decreasing the concentration of RCl to half, the rate will also be halved. So this is the correct answer. Now let us move to another question, which says that what is the rate of second order reaction? Rate constant, unit for the rate constant of second order reaction. So I have given you a formula to directly found the rate constant, which is as like this: mole 1 minus n liter n minus 1 per second. So here the value of n is 2, so it will be mole 1 minus 2 liter 2 minus 1 per second, that will be per mole liter per second. So it will be the answer. So according to this, it will be this one, that is per mole per second. Okay, so the option is not, so this one is the option. Okay, so do not get confused with the decimeter cube, because 1 liter is equals to 1 decimeter cube. It is nothing new to happen. So this is completely wrong. So if you want to find out that what is the order of reaction for this rate constant, you can also do that. So suppose it is given as per second. That means mole is having a power of 0. Also, the liter is having a power of 0. So if you put it in the formula, that is mole 1 minus n liter n minus 1 per second. So if you either equate this equation with this or this with this, you will get the value of n as 1. So this is for a first order reaction. First order reaction. Similarly, if you look at this formula for this unit, and just it is given as mole decimeter cube, or you can write it as liter per second, mole per liter per second. And if you equate this with this, say this equation, that is this one, and either equate this with this or this with this, you can get it as 1 minus n is equals to 1, so n is equals to 0. So for this is a zero order reaction, unit rate constant. So if you know this, say this generalization, you can easily solve for finding the unit of the rate constant just by equating those with that given values. Now let us move to our next question. So if you want, you can see the solution also. The first order, it is given in a different way, and so this is the answer. Now let us move to our next question, which says that for a reaction system, the volume is suddenly reduced to half of its value by increasing the pressure on it. If the reaction is of first order with respect to O2 and second order with respect to NO, the rate of reaction what will the effect on rate of reaction? So if we write the rate law according to this statement, which says that the rate of reaction is first order with respect to O2. So if you are writing it like this, so it is saying that first order with respect to O2 and second order with respect to NO. So this is the statement that is given, and one statement that is made here is the volume is suddenly reduced to its half. So the initial volume is reduced to its half. That is final volume is equals to 1 by 2 of initial value. Sorry. V final is equals to 1 by 2 of initial. Yeah. Now it is asking what will be the effect on this rate of reaction. So if you have to solve this question, you must know very well what is the relation between this, say, this volume and number of mole. So you must have this idea about it. So suppose if the volume is, so if you calculate the number of moles like this, PV is equals to nRT, the temperature and all things are similar, only the volume has changed. So we can write it as PV is equals to initial n initial RT and PV final is equals to n final RT. You can write both those equation in terms of this. Further, if you just replace it by this V initial V final by this, so it will be PV final okay, so let me say it. Yeah, so it will be PV initial by 2, that is equals to nRT Similarly, it will be P V initial by nRT. If we equate both these equations by taking PRT as common, PVIRT as common, that will give you Ni is equals to Nf by 2 is equals to Ni. That is N final is N initial into 2. Now, we have to say that what is the effect on this rate of reaction. So you can see here very clearly that since we are increasing the volume here, we are since we are decreasing the volume here, we are increasing the number of moles, and that is what by that is also by you can say by 2 times. So suppose if we say that it is according to this rate law, if we write, so if we are just increasing the number of moles by 2, so if it will be written as the rate of reaction will change by 2 into 2, that is, so the final rate of reaction we can write it as R is equals to K into O2 to the power NO2. So it is R, and R dash can be written as, so since we have increased this thing, so it will also be say, so overall you can say, so if you put this value all over here further, so it will be like this. Now since we have assured this value, you can put it here. Finally, it will be increased by 8 times. Okay, so we have again find it dx dash by dt. So it will be like this. Okay, so this is the solution. Now let us move to our fifth question, which says that for the non-stoichiometric reaction 2A plus B, C plus D. So here non-stoichiometric means that it is a non-elementary reaction. So you cannot just simply say and okay, so this is a first order, second order by looking at the rate equation. The following kinetics were obtained. So this is the kinetics here. So this is experimental data that were given, and we have to find that what is this rate of reaction, or you can say what is the rate law of this reaction. So if you write it here for all of this, so if you write this all of this, so it will be like this R dc by dt. So the rate equation was like this, A plus B in C plus D. So if you write the rate of reaction in terms of this concentration of product, so it will be R is equal to dc by dt kx by by. So these are the reactants, and x plus y are unknown. Now if you put all these values, that is given in the say table, so it will be 1.2 and 10 to the power minus 3 for 0.1 and 0.1. Then again into 10 to the power minus this one and this one. Now we have three equations and two variables, that is x and y. So we can solve this by taking any equation. So suppose we divide this equation by this. So what do we get is that, so this k and k gets cancelled by each other. You can see very clearly that if we are just say we are increasing the rate of reaction, so we are decreasing the concentration of B by 2. So if you multiply the concentration of B by 2, there is no effect on the rate of reaction. It remains constant here. So that means the rate of reaction is independent of B. So this value of y here is equals to 0. Why? Because if we are increasing the doubling the rate of concentration of B from 0.1 to 0.2, there is no net effect on the rate of reaction. It is remaining constant. That is 1.2 into 10 to the power minus 3 and 1.2 into 10 to the power minus 3 only. Now further, if we keep this constant, now we keeping this constant and we are doubling this one, that is 0.1 into 2, so it will 0.2. Then we can see a clear jump of this multiplied by, so we can see that 1.2 into 10 to the power minus 3 is going to 2.4 into 10 to the power minus 9. So we can say very clearly from here that as shown the rate of reaction remain constant with respect to be the concentration of 0.1 to 0.m. So and in case of A it is doubled, therefore this x plus y will be say 2. Okay, so the overall rate will be A, that is A is raised to 2 and B is raised to 0. Sorry, A is raised to 1 and B is raised to 0. So this is the correct rate law for this. So this is the correct rate law for this. Now this 5 questions I solved earlier. Now I will see the later on 5 questions. So we will not solve it. You have to just solve it by yourself. So say we have a reaction here that is going AH plus BG is equal to product, and it is given that when the concentration of both the reactant G and H is doubled, the rate is increased by 8 times. However, so we will write the statement one by one very well. So it's saying that if we are increasing the concentration of this G and H by doubling, so we are doubling it, say we are doubling it, then the rate of reaction also becomes 8 times the earlier. So suppose if R initial is the initial rate of reaction, then this R1 will be equals to 8 times of Ri. Now what is the next statement that is given? It says that however when the concentration of G is doubled, so this concentration of G is doubled, by keeping the concentration of H fixed, the rate is doubled. So it is saying that suppose we are taking another condition which says that we are doubling this rate reaction by G. So suppose this X, this is Y. Okay, and this is Y. It is kept constant, no change in concentration of this. The overall rate of reaction is doubled. Okay, so this is doubled by this. So we can say that it is initial to the power 2. This means that this thing here is equals to 1. Why? Because if we are doubling this, so if we write the first initial rate law, it will be, so I'm not considering rate constant here. Okay, we can write it here, so it will be more absolute. So if we divide both of these equations, okay, so you can see very clearly here that the x value will be equals to 1. Okay, so this x value is equals to 1 because we'll get it as 1 by 2 is equals to 1 by 2 to the power x. So it will be only equal when x is equals to 1. Now if you have find the value of x here, you find the value of x here, so you can put this thing here. Now if you divide this equation, this both equations, then we will get it as Ri by 8 Ri is equals to 1 by 4, okay, of G into H, that is x and it is y. It is also G, x and it is y. So its x value is 1. Here also x value is 1. Okay. Now this 1 by 8, we can write it as 1 by 4 is equals to this thing. That is y. So if we just solve this question, so it will be 1 by 4, 1 by 2 y. So it is clearly seen visible that y should be equals to 2 for this equation to be balanced. So what is the overall rate of reaction? So it will be 3. 1 with respect to G and 2 with respect to H. So I will not solve this further question. I just give you the direction. The rate of reaction of platinum is 0 order. What are the rate production of N2 and H2? So for this you just need to know the equation, that is Haber's process, which is N2 gives NH3, 2 NH3, that is 2 3 just 6, it is 3, and this is the equation that we have. So it is a 0 order on platinum. What are the rate of production of N2 and H2 if K is given? Okay, you solve it by yourself, so you just have to take the rate law and solve it. Now here are some assertion questions that I've given. So if you know the theoretical part very well, then you can solve it. So it says that both A and are true, and R is the correct explanation of A. The second is that both A and R are true, but R is not the correct explanation of A. A is true and B, R is false. So what are the statements says? The first statement says that order and molecularity are not the same. So yeah, it is very true that order and molecularity are not always same. Order determined experimentally, and molecularity is the stoichiometric coefficient of the rate determining steps. Yeah, so the statement is very correct. So what is the order? So it is basically the, say, the experimental thing that is determined in the complex reaction not so easily, but molecularity is simply the sum of the stoichiometric coefficient of the RDS. So this is the answer should be both A and R are true, and R is the correct explanation of A. Now next statement says that statement 1 should about statement 1 and 2 we have to say what is true and what is false. Statement 1 says that the order of reaction can be zero or fractional. So it is very true. We cannot determine the order of balanced chemical reaction. So it is also true. So if it is a complex reaction, we cannot find it. It is not, or not always the stoichiometric coefficient. So this both are true, but it is not the correct explanation. This 2 is not the correct explanation of this first one. So statement 1 is true, statement 2 is also true. Statement 1 is true, statement 2 is true, but statement 1 is not the correct explanation for 1. So this is the correct answer. Okay, so this was for today's lecture. So in the tomorrow's lecture, we will basically seeing the differential rate law for the zero, first order and the pseudo first order reaction. And then we will see the temperature dependent, that is Arrhenius equation. So thank you for joining today's lecture. So if you have some question, you can ask now. Yes, Mahasangram. This B is correct answer for 9. Okay, thank you.